Example number 1. In the beam shown, determine the maximum horizontal shear developed when the section is rectangle with base equal to 250 millimeters and height equal to 500 millimeters. Also, compute the maximum shearing stress developed in the fiber at 1 meter from left support and the shearing stress at 40 millimeters from the top fiber of this point. So, as what I have told you earlier, that in solving for the shearing stress, all we have to do is draw the shear diagram and get the maximum value for us to be able to solve for the different shear values or shearing stress values. But first, all we have to do is assign letter to every change of loading. So I have here letter A, and this is for letter B. Then at the end here is C, and at the rightmost end is D. And of course, we're not after the horizontal force, we're after of the vertical force, since that's the reason nga na natin braking. This is AV, and on the other side here, this is, I'll call it CV. And also we have a distributed load that we need to get its resultant. So the resultant would be 1/2 of 400 times 30. So that's 600 newtons. Okay, so let's solve AV. So we will be solving AV by summing up moments at C. So summation of moment at point C para ma-solve si AV. So you have AV times 4, for this is the moment arm of AV, and then plus the 200 times 2, and then minus the 600 times 1/3 of 3, so that is 1 equal to 0. So we will obtain now a value of AV. So the value of AV is 200 times 2, or 600 minus 200 times 2 divided by 4. The answer is 50 newtons. That is the value of our AV. And then summing up forces, vertical equal to 0, we will have AV plus CV minus the 600 as the resultant of the triangle, and minus 200, and that's equal to 0. So we can now solve for CV, and our CV is 600 plus 200 minus 50. That's 750 newtons. Okay, so right now we're going to draw the moment shear diagram, and for the meantime, let us now proceed for drawing the next free body diagram. So I'm gonna draw another beam containing the same amount. Okay, and I'll drop down a line. This line will represent the line for I'll just write letter first. This is for A, this is for B, because I forgot to write here, and D, and then here this is 750, and then here this is 50. Right, then I'll drop down a line. So I don't need much line kay we're only until shear diagram. So unlike sa kung na moment kay patas ang yun nato siya nga line. Okay, right, and then the horizontal, oops, So this represents the zero shear line. Okay, so what did we do from the last time? We plotted directly in the diagram here. Let's start with 0. And then, since our 50 is upward, then it's going to be found here, 50. And let's connect that with a vertical line. And the value here is, it's not writing anymore. Okay, that is our 50. And since we're plotting now point B, and then comparing A to B, walay load between them. So, kita mo first buhat sa line. And this is at 0 degree. And this value here is still 50. Next. At point B, there is no concentrated load. That's why kausalan ta mo agi. Okay, so from B to C, at point C, there is a concentrated load because of this 750. So there would be 2 points sa atong shear. But the first point would be the area between B to C. As you can see, the area between is 600, diba? Triangle. 400 times 3, that's 1,200 divided by 2. So that's 600. So I'll just write here the 600. I just forgot to write it down here. Well, anyway, just refer here. You have a 600. All right, so what we're gonna do now is subtract, no? So 50 minus 600 is 550, right? So ang 550 is found here. I just assume that this is the location of the 550. Okay, and then how do I connect the 50 and the negative 550? So basically, we're gonna connect it sa kung unsa iyang illustration. This is at first degree, and as you try to observe, if we try to draw a vertical line from left to right here, so ang nahitabo sa line kay it grows longer, so ni-increase ang vertical line. So this is downward man, so negative, na ang vertical lines nga atong gi-draw is increasing, so it's negative increasing. So how do you draw a negative increasing? So this is negative increasing. Kaya mao man ni siya ang positive increasing. So negative increasing. So let's connect negative increasing. Oops, I used a different color. So what? Right. And this is at second degree. Okay, and as you observe, we have here a point of inflection, but don't worry, we're not after of the moment, so let's just leave it there. Okay, so we're after of the shear values. So let's proceed. We have the negative 550, and we have to pair it with 750 upward. So therefore, we're going to add the 2. Negative 550 plus 750, it's 200. Yes, that's 200. So let's just connect these two dots, and this is 200. Okay, so we're connecting now C to D, and at D there is a concentrated load, so there would be 2 points. Pagahuman, from C to D there is no load here, so pasabot ana, we're gonna maintain same line, horizontal. And then this is also 200. This is at first degree. And what is the last value? It should bring back to 0. So we have positive 200 and downward nga 200, so therefore we're gonna subtract the 2 and it becomes 0. Right? So what is the value of our maximum shear force? So let's just write now down here. What is the value of our maximum shear force? So pila man na tong max. Remember, you can get the maximum value, so regardless of the sign. So you just choose the numerical value, unsay pinakadakong numerical value regardless of the sign. Okay, so sa tanan nga positive side, here I'm looking at this picture. Sa tanan nga positive values, ang 200 may pinakadako. But sa tanan nga negative value, this is the biggest. So therefore, the maximum shear, regardless of the sign, it's equal to 500. I'll rewrite it down here. This is 500. Hindi naman siya makagi. 550. And this is in newtons. So that is our maximum shear force. Okay, let's start solving the first question. Determine the maximum horizontal shear. So maximum horizontal shear, so the formula, shear stress is equal to VQ over IB. Okay, so our V here is Vmax because we're gonna find maximum shear. So therefore, our V to be used now is also in max. Hindi naman siya mo agi. And then the Q over the I and the base. Right? So let's draw the figure. So according to figure that the height is 500. The height is 500 and the base is 250. Okay, and then of course do not forget that we're going to draw the neutral axis because the location of the maximum shear stress is found at the neutral axis. So here, this is the location of our neutral axis. And then, if this is our neutral axis now, let us proceed in getting the I, or the, yes, I. So ato lang tag sa tagsaon. Let's solve for the I of a rectangle. What is the I of a rectangle or moment of inertia? So it's gonna be base h cubed over 12. There. So the base is 250. Why is this not writing? Okay, kalit lang ako sa ning